right. So, how's your day been?
Not good.
Not good. Why not?
My face is warm.
My face is warm. Lunch sucked. What else is it? Did I get? Nothing. My day's been okay. But I was just waiting to see you guys all day. Anyway, so this is, it always says the day and then you guys are the B group. So today I'm recording you and I will be posting that, and A's and the distance learners have to watch it. So we're going to try to all be doing the same thing on the same days. Does that make sense? So tomorrow is just a small amount of notes and then a limit circuit to review limits. They'll be doing that. You guys will be doing the circuit at home. Yeah.
Does that mean that the video notes aren't going to be posted until like late each day?
Yeah. Yeah, or some of them I have made ahead of time, but like today's isn't an actual lesson, so I don't have it made ahead. Some of them I have from last year, some of them I'll make at home. So the answer to that is sometimes you'll have to wait until this time of day, but not always. So just whenever it gets underlined, the link is active. Today I can't. I'll do it after this hour. So this will get underlined. Does that answer your question?
Oh yeah.
It kind of did. Sometimes you'll have to wait. So the first thing I want to make sure you guys do at home, in here, or whatever, is everybody's going to join my Remind, because that's my favorite way to get a hold of you guys. Plus, when I find a funny meme, I like to put it up there. Right? So, text at, if you can't see it, A7H28B to 81010. A's and distance learners, same thing. I should have everybody in my Remind by the end of the day today. So that's our first thing. Were you guys good with the Google Form submissions last year? It works really well on mine. I can sort and look, and so I'm going to stick with it unless it starts bugging me. Toby, what did you take for your other class?
I haven't done it.
Oh.
It's just like consistent.
Oh, okay. All right, once you've got that done, we're going to go get into 3 things that we need already this week. I do try to, not just do notes, worksheet, notes, worksheet, notes, worksheet. That gets kind of boring. And I'm going to try with this new system to avoid that drudgery all the time. So this week we'll be in Delta Math. We'll be not in AP Classroom, but I'm still going to have you register. And we'll be doing a quizzes too. So next thing, take out your computers, and we're going to get you into this year's Delta Math. Now, if you're at home and you're the distance learners from Zimmerman, if you didn't use Delta Math last year, you'll be getting in different. We do have Zimmerman in here as well, but I think there's 2. So go to Delta Math, and you guys already have accounts. So all you need to do is, you don't need to make a whole new account. In here where you would normally go in last year, you go to Tools, and it'll say something about, in the top right, Cal, what does it say? Under Tools, it'll say like Manage Courses, or she's not in, she's so slow. So once you're in, for you guys, because you'll just need to go to the, so go ahead and log in to your last year's, and then go to Tools, and do Manage Login and Courses. All right, and then when it says add teacher access code, you're going to do 599802 and pick the class that says, what did I label it, Gabe? I think I labeled it BC5. Yeah, so pick the 2020 BC5 one. So Tools, Manage, Login Courses, enter that code, 599802 right here. And we have plenty of time, so.
Come on, Joe.
What?
We didn't get a shirt.
We didn't get a shirt, I know.
Can we please write on the walls?
Not yet, but yes.
Maroon.
What?
I think it's what? So when you go to the classes,
Yep.
it says on class.
Yep.
And then you can just drop down menu, switch it, so you
Oh,
go to
so you don't have to do the tools.
So you're not in both accounts either.
Oh, hey, okay, here's a better idea. Shh. Repeat it, Zach, but louder.
Well, if it says that you're in like the last year's one, you can just like hit edit and then switch it to BC5, so you're not in the one from last year. But
I archived it, so I don't think it'll matter. So if you're in, you're in. New people to Delta, Zimmerman. You need to do the login, unless you've used Delta Math before, then you'll do the same thing.
Yeah.
But if you've never used Delta Math before, you guys will need to, create an account, and it'll ask you for your email, password, just do your, school stuff, and then it'll eventually ask you for a code, and you'll enter the 599802. If you're in Zimmerman and you don't have access, can't get in, just shoot me an email. Okay? Or a remind now, because you should be in there. Reminds are easier. Next, we're going to go get into AP Classroom. All right? And you guys know how that works because I had you last year, but that's where we pay for things. We test in there sometimes. So for the AP Classroom, you go to myap.com, and you guys should all be in there because of last year anyway. You just need, again, a code. So I got to go to period 5 here. Give me a second. I'll pop up our code. Don't enter those. Those are ABs. I have you guys on the next page here. So here we go. So you go to myap.collegeboard.org. And you were in there a lot last year, so you should be. Have you guys gone in here today already for a couple of your AP classes? Nope. I should have then had the spreadsheet so you could go enter all of it in today. Oh well, that's okay. To get into my class, A923MN. myap.collegeboard.org. You should probably bookmark that. Should have done it last year maybe. Same with the Delta Math. I would just grab these. You guys know how to, you just grab the little lock and dump it onto your toolbar. myap.collegeboard.org. And then you should have all your stuff in there from last year, so you should just be able to get in. You in, Toast?
We have a student ID.
You don't even.
No one's needed it today.
What says file?
Oh, yeah, don't it. So we'll get you all in there. It'll probably be a while before we do anything in there, to be honest, but actually, it might not be too long because I might have to do a review test that way. All right. Anyone still working on that one? Okay, I'll wait for you. Do you still need the code? Nope. Okay, I'm gonna go back. So, back to here. We should be in Remind, we should be in Delta Math, we should be in AP Classroom. All right. There's also, last year we did the quizzes. I kind of liked those. I could easily see results and stuff, and they've actually even made it better. So, I think we have a limits quizzes coming up this week. I'm going to get you into the class. All right. You click on that, and did it pop up with this on yours too? Sandra LaRue invited you to a class on quizzes. When you clicked on it, did you get this window? Somebody speak to me. You're behind? I'll wait for you. So go to Schoology, click on this quizzes. That's not actually what I thought was going to pop up, but we'll see. Did you get sent to this? Okay, do accept invite, and I'm hoping it dumps you into the class I created for you. Usually there's a code. I don't want to be in my own class because I'm...
I did not.
You don't have one? What's it doing when you click on that?
Just purchase.
Is it just spinning?
Say I'm in your class.
I don't know. I'm not in it right now. So if it doesn't work, I'll take a look at it tonight and see what happened when you guys, and if I need to send a remind with a new link or something, I'll do that. I don't,
Sorry, this
so-
class in my home is out.
I have this.
is out everybody's the same? It worked for you.
Where did you find it?
Interesting.
Yeah, just say it invited me, but I have this.
Well, we'll figure it out. If you got in, great. Those of you at home, it looks like some are in, some are not. So we'll fix it before you. I think quizzes is on the docket for Thursday or Friday. if I have to, I'll just send a link where you're not actually in a class. So we'll figure that out if you didn't get there. All right. So some of you, so back to this. We're all in Remind. We're all in Delta. Did you get in AP Classroom, Cole?
Yeah.
Okay, we're all in AP Classroom. Some of you, how many of you didn't get into quizzes? Just so I can see. Those of you at home, it looks like about a half of you won't be able to get in. I'll send a remind sometime in the next day or two with a new link or something. All right. I don't think it's on the schedule for a little bit. All right. Next, how about we do some math? Yeah. All right. So we actually start off nice and slow in here. We're going to review and bring stuff back. It's always a little awkward at first, and then stuff just starts to come back. I'm gonna have you guys. I'm not supposed to pass out papers. If you could come up and grab a paper, because I don't have a note packet for the review. It'll kind of all be separate. We are going to
I got it.
go back to the very first thing we learned in here last year. Do you remember what it was? Limits. And we're not going to add anything new to it. We're just going to review, but we do it for a few days. So it's not like you need to have all your limit knowledge back today. Today we're going to make a flow chart. All right, and that's what you're going to submit to me actually. So all you got to do is make this. So tomorrow when you guys are at home, this is going to say A group, and B group and distance learners, it'll say what to do. All right. It's very short notes tomorrow, and then like I said, you'll be working on a circuit. Do all of you guys have a printer at home? If you don't, and or you don't want to use up a lot of its ink, I'm going to try to have stuff ready to roll here before you leave. So if you want to grab the circuit and you want to grab the skills reviews, you don't have to print it off at home, you can. Okay? But I can't pass them out. Those of you at home today, again, you can pick it up tomorrow if you want, but it says to start the skills review. It goes from limits all the way through integration. I don't have a due date on it yet. So we'll just see how we do. Fair enough? All right. Don't go past limits, though. It actually, Toby, is it just one page limits? I think? Yeah, I think it's one page of limits, and then it goes to continuity. Don't go past continuity this week, just because we're not going to do derivatives. We'll start Friday or next week. Okay. So this is just to review some stuff. But I want to make a flow chart with you, and then if you want, we'll pick that up and you guys can start working on it. As usual, there's a key posted. As usual, what do I always say with the keys? Don't copy them. It's deadly. And we know that. So, and then tomorrow, I'll take questions on if there's any you're stuck on, and then we'll work on a circuit. So actually in BC, we end up with fewer notes, less homework, and we work a lot. And last year and the years before, they worked together a lot. We can't do that, but we might. Did you do anything in the spring in any of your classes where you were able to work together well, or was it always just kind of a trade?
No.
Did anyone try a Jamboard?
No, man.
Google Jamboard might be like Luke could work with Carl, or no, Zach could work with Carl from across the room, and you're writing on the same the whiteboard, you know? So like, they're like, you like to work with Regan and she's distance learning, right? Like you could Jamboard it, but I haven't used it. We'll practice maybe later in the week. So that way if you want to work in groups, like some of you boys always worked together last year. You could still all be up on the same Jamboard and you could see each other's writing. It's called, Google it tonight. Write it down. Google Jamboard. And see, I've never used it.
How would we register mice on our paper?
Yeah, I think I was doing it with the trackpad on my laptop and it worked okay. I don't know with Chromebook. It's just a thought. I Googled it and I brought one up, but I wasn't on it with somebody else. I was just on it myself. So I don't quite know. Like if Toby's writing, I think you can see it if you're on the same Jamboard. Someone wants to figure it out for me, that'd be awesome. Okay? But I think that might be a way where we can keep working together so that if we're all stuck on number 5, somebody can pop up a Jamboard and you guys can at least write together. We'll try it. It said it's supposed to be good for math. So we are going to make, and those of you at home, this is what you still need to turn into a Google form for me today. The same Google form as everybody else, where you normally I wouldn't collect notes, but people at home, I want to make sure they're doing it. So we're going to do a limits review flow chart, and then we'll see how much comes back, and we'll just kind of go with the flow. Sound good? What do I get? Good? All right, here you go. So at the top, we're going to talk about first limits as x approaches some constant of some function and what the possible things are. All right. So no matter what, if x is approaching 7, what do you do with 7? Plug it in. We know that. So you plug it in, and these are the options when you. It's not actually a flow chart because it's just going to be sort of a diagram, I'd say. If you plug it in, best case scenario, you get a number, or you get a number over a number. Why do I say that's best case scenario? Because you're done, right, Toby? You're done. That's your answer. Keep in mind 0 is a number. So if you get 0 over 7, your limit is 0, right? So number over a number, or just a number, you're done. We like that. That rarely happens. All right. Next case scenario. You get a number over 0. So think about that. So you had some rational function. By rational, I mean it's a fraction, something over something else. And if you get a number over 0 on a direct plug, do you guys remember what happened there? Vertical asymptote. Yep. So let's go down here. That means graphically you hit a vertical asymptote. And again, I'll just write VA. You know what that stands for. So think about if, Zach, you hit a vertical asymptote, right, at C. So go ahead and put a little graph on here. What are your possible answers for this? If I'm looking at the limit and I hit a vertical asymptote, I have a very finite number of answers. This is an infinite number of answers, any number over any number. This only has 3 possible answers. Do you remember what they are? What did you say? Positive infinity. Now think about when that happens, okay? So positive infinity happens when it's a one-sided limit. Do you remember, Connor, what I mean by one-sided limit? Pop that like from the left or from the right, Cole? So if you're from Zimmerman, you're like, how does she know all their names already? I had them all last year. So I'm not an idiot savant. All right, so this goes up like that. That would be what we call a one-sided limit from the left, and its answer is infinity. This would be a two-sided limit whose answer is also infinity. Do you remember that? So what are the other possible answers? Negative infinity, excellent. With the same, it can be one-sided, or they both have to be going, right? So what's the third possible answer? It does not exist, and in what scenario does that happen? And how do you figure that out if you can't look at the graph and don't have a graphing calculator? Like, how does Callie know whether it's going up or down or what to be? Creeper. Yes, you'd be a creeper. And again, some of our language to Zimmerman might be a little odd. So you become a creeper. So go ahead and write creep. And let's do an example, just in case Ethan's looking back there like he's super confused. I'm just kidding. You're not. You just look ugly as usual. Oh. It's good to be back, isn't it, kids? All right. So let's do our limit as x approaches, 2. Now, remember, that means for both sides, right? So all 3 are a possibility. They're either both going up, both going down, or one of each, which gives us a D and E. So let's approach from both sides. Let's throw the vertical asymptote in there, which means the issue's only on the bottom. Hey, what happens when they're both there? Like if there's an x minus 2 on the top, and I cancel. There's a hole in the graph, exactly. But when it doesn't cancel the issue off, you've hit an asymptote. Let's make the top be a number over 0. So Gabe sees this in his head, he plugs in a 2, and he goes, oh, 5 over 0 hidden asymptote. Right? And because it's a two-sided limit, Luke, or Gus, right? It's either going up, down, or one of each, and that's where you have to be a creeper. So you pick a number really close to 2, but to the right of it, and you do sign analysis, right? So I'm thinking in my head, what number am I thinking? I'm not thinking 3. Because a lot can happen between 2 and 3, right? What number am I thinking? 2.00011, right? And I'm just looking at the signs, and when I come in from the right, I'll put a little plus there, I would have a positive over a positive. Doesn't matter what they are. They're both positive from the right. So I'm going like this. Do you remember that, Luke?
Oh yeah.
He? Luke or Lukey?
Luke.
Lukey poo! Alright. So then when I come in from the left, and again, these are right, left. The other ones are pluses, minuses. So let's go take a look. When I think of 1.99999 forever, the top is positive, but the bottom will be negative. So what's the answer to this? True D&E, right? Because I was a creeper. But, Connor, the minute I go like this, I can't be a D&E. Well, by nature, infinity doesn't exist, but it's a refinement, right? If I had come in from the right, then what's my answer? Positive infinity. Does that make sense? All right, so we've got that situation down. Last situation was the humdinger. What do I mean by that? The one that had it all the work. Like, it's like crap. I got, what? 0 over 0. See, I think limits are coming back, which is good. Because, all right, 0 over 0 causes a lot of issues. So let's talk about how you deal with it. Let's talk about the beginning of the year first, and then we'll talk about what happened at the end. So, what's the very first thing you would try to do if you could? Factor. Yeah, if it was a rational function or a polynomial over a polynomial, one big go-to is to factor. Because you want to find whatever's causing the 0 on the top and on the bottom, right? So you'd factor, and then what would you do? Cancel, and then what? Replug, but don't forget, don't just have it be an algorithm in your head. Let's throw a little like, easy example up here. I'm going to throw a 0 in the bottom by hiding an x minus 3. Guess what I'm going to put on the top? I'm going to take a limit. As x approaches 3, I hid an x minus 3 on the bottom. What do you think I'm going to throw up on the top? An x minus 3. Maybe I could have it be a 2x minus 6 or something else that factors, but I'm going to go like that. All right? Now, when I factor the bottom, is this coming back, Lodmeyer?
Yeah.
Awesome, you're the best. I don't care what everybody else says about you. All right, so what I'm doing is I'm finding what's causing that 0 in both places, right? I'm going to cancel it off. The minute I do that, what it is this is really the graph of 1 over x plus 3. That's really what it is, Tyler. Right? But there's a hole in it. What's the location of the hole? My limit is now 1 what? What's my limit? What's my limit, Carl? Limit as x approaches 3 of 1 over x plus 3. 1/6. Remember, the limit's the y value that you arrive at when you approach 3 from both directions. Correct? 1/6. The limits are y values. So my question is, what's the location of the hole? This is so fun. I missed this. What's the location of the hole? 3 comma. And I challenge you that you should really know exactly what that graph looks like. Let's talk about it, okay? Because it helps if you don't have a calculator, Cal-Bell, to know, not Cal-Bell. So watch. You don't need to write this down, but go take a look. My actual graph is 1 over x plus 3. Do you guys remember what the graph of 1 over x looks like? Y equals 1 over x. Toby, you're doing it. What does it look like? Let's suppose Connor's like, I don't know. I forgot, right? Let's pretend. The graph of 1 over x is a parent function. right? He'd start going like this. 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third, right? And a fourth and a fifth and a sixth and a seventh. Agreed? And if you went the other way, 1 over a half is 2, and 1 over a third is 3, and he'd go, oh, it's that guy. And that guy. Where is its vertical asymptote? X equals 0. Where do you think it's going to be when it's 1 over x plus 3? Where's your asymptote? Where is it? Not asymptote, sorry. Back to the original. Yeah, right here. Where is your asymptote on this guy? What color? Negative 3, right? So it's this graph, shoved 1, 2, 3. It's this guy. So this is the graph of this, except where am I going to put the hole? When I came in at 3 from both directions, where did I arrive? 1, 6, but it's not really there, right? So I'm going to go over to 3, 1, 6, and I'd put a little open dot there, just so you get how that works. Okay, suppose it has roots in it. Do you remember what we did last year when we had like the limit and it was like the square root of x plus 3 minus 1 over 2? You remember? There's a class. All right, so I'll remind you. The reason you don't remember is because at the end of the year you never chose to do it that way. Factor cancel held strong all through the year, right? But let's see if somebody remembers. Somebody blurt if you do remember. What? Gabe, do you know? Yes. Multiply top and bottom by the conjugate of the root one. Do we remember what a conjugate is? Do you need me, Cole, to make a fake one of these? Okay, I'll make a fake one to start. That when it went silent like that, I'm like, okay, they remembered their vertical asymptote stuff. That's totally fine. So let's take the limit as x approaches 2. Let's do the square root of x plus 2 minus 4. Why did I choose that? What do you get when you bad choice. What do I get when I plug the 2 in? 0. What do you think I'm going to put on the bottom? I want to get 0 over 0. I'm trying to create an example of that. It's me creating a test question. There you go, x minus 2. Do you see how I create a test? I'm like, okay, let's have a root in it and have it approach 0 over 0. So there we go. When Gabe said conjugate, Gabe, I'm going to erase this. Can you remind us of, see, we want to suck out that x minus 2 so we can cross it off. Same end game as the factoring. So Gabe, what did we say we would multiply by? Excellent. Yes, the conjugate of the one with the root in it. It's not like algebra 2 where you're always doing the conjugate of the denominator or whatever. So, Gunnar, does that make sense? And this right here is really just multiplying by 1. So I'm just going to give it a facelift, right? So watch, and I'm going to do this fast. So when I do this, I get x plus 2 root x plus 2, which is just x plus 2, right? And then you do it on the bottom, and then you'd replug. Does that make sense? Okay, so I'm not going to finish that off, but that's what Gabe meant. All right, then also, there's some tricky stuff. I'm almost done. Now with the tricky stuff, you probably don't remember it as well because we're going to go, Zach, go like this. Let me see if anyone remembers. We're going to go like this. Later in the year, for almost all of these except this guy, we chose to do something else. Couldn't do it in our limits chapter because we hadn't learned derivatives yet. Do you remember what it was? What was it? L'Hopital. Yes. All right. Is it coming back, Lucy? Or you're going to use L'Hopital. And I know this isn't the best map, but it's all we need. L'Hospital's rule. All right, let's see if you can, and you can still use that. But what do you have to remember, Carl, in order to use L'Hopital's rule? Remember, if you get 0 over 0 or infinity over infinity, what can you do take the derivative of the top, I better stand closer, over the derivative of the bottom, and then we replug. And if we get 0 over 0 again, we take another derivative. So Toby remembers her product rule. And what's the derivative of sine? Cosine, right? It is actually easier than remembering a lot of stuff with your trig. But there are two that we did learn that you probably forgot, but we used them as aids in chapter 1 last year. This guy is always something. My guess is, though, Gunnar, you forgot, right? So let's L'Hopital it. What's the derivative of sine? Cosine. What's the derivative of x with respect to x? 1. This is really cosine x. Do we agree? Now plug. What's cosine 0? 1. Boom. We learned that that was 1 and we proved it. Why don't you remember it? Because what did we always choose to do later in the year? L'Hopital. So L'Hopital is actually very good if you remember your derivatives. There was another one that you probably forgot. Limit as x approaches 0, 1 minus cosine x over x. Notice that's 1 minus 1 over 0, right, Kelly, on the direct flow. If you forgot what it is, you might say, I'll just go graph it. Yeah, you could if you had a calculator. Go ahead, but you probably wouldn't for this type. Let's L'Hopital it. Okay? What's going to be on the bottom? 1. Derivative of that dx is 1. On the top is the derivative of sine, cosine. Oh, by the way, Zimmerman, we remembered our derivatives and integrals with sine, cosine, negative cosine. So what did I always say? St. Cloud, negative St. Cloud, and it ends the way it began. So we derive this way, we integrate that way. So what's the derivative of cosine? Negative sine. So you can think of it as 1 minus negative sine or just sine, right? Or you could say the derivative of negative cosine is sine. It depends on how you want to do the negative. But this is just sine x. What's sine of 0, Tyler? Do you remember? 0. So we use these sometimes if we can spot them or find them in our problem. Sometimes it helps to change tangent to sine over cosine, right? So the tricky ones you just have to play. What could you change this to if you saw that in a tricky problem that was causing you an issue? What did you say? Cosine squared. Yeah, there might be some, I won't do like the double angle identities and that stuff, but there might be a few. All right, so now all we're going to do is a tiny little bit of practice of some weirdos. Some stuff where, like, you're having a hard time. Actually, I think I'll just do one. Very common one in BC is to have an absolute value. The minute you see that, L'Hopital's is out. Because what's the derivative of absolute value? Well, it's an operation, right? It's like saying, what's the derivative of addition? It doesn't make any sense. But what I'm going to do is create a 0 over 0 with my favorite number 3. So that means I need to have an x minus 3 on the bottom and an x minus 3 on the top. Right, Zach? So this guy right here is really a shift of this guy right here. Do you agree? Where has it been shifted? It's the same graph. It's just been shifted 3 to the right. Yeah, the issue's now 3 instead of at 0, right? Let's talk about what that issue is. It's not an asymptote. Because the x minus 3 is living on the top. The problem's in both the bottom and the top. Does that make sense? There's not an asymptote there. And it's not a hole. So let's see if you can figure out what it is over here. When you don't know something, you be a creeper. Does that make sense? So let's just start at 0. No, we have an issue there. And let's move to the right of 0. If I move to the right of 0, won't I just have x over x? All the time. Right? Absolute value 7 over 7, absolute value 8 over 8. It's always going to be what to the right of 0? No matter what. 1. Right? So it looks like this at 1. Now if I go to the left, then if I was like saying doing negative 5, I'd have 5 over negative 5. Or negative 0.01 over 0.01. Do you see how we're going to have a negative 1 no matter what? It looks like that. This is a good one to memorize, the graph of it, because the rules don't apply. There's not a factor cancel. You can't lope at all. You really need to understand the graph of this. Does that make sense? So what is my limit as x approaches 0 from both sides? Well, it doesn't exist, correct? But if I did this, boom, boom. Now the answer is what? 1. You see how if you get it, like if you have a weight, now let's go over here. This graph is just a shift of this one. Correct? It's going to look exactly the same, but the issue is at 3. And everywhere to the right of 3, that's going to be 1. Try 11. You're going to have 8 over 8. Right? Try 3.0001. You're going to have 0001 over 0001. So that looks like this. Everywhere to the left is like this. So if I were to go like this, I'm going to take my pen right here. If I were to go like that in black, what's your answer? -1. If I go like this, what's your answer? 1. And if I were to go like this, what's your answer? Awesome, Deanna. Does that make sense? Now, if I just threw a 2 out front, remember limits are malleable. So, do you know what I mean by malleable? Gumby. You know who Gumby is? You don't know Gumby?
Green guy.
Yes, Gumby. He's like the stretchy guy from Saturday Night Live. It's from the 80s, but it was a thing. He can stretch. He can stretch. Google Gumby. Anyway, I'm going to stop right there. And what we're going to do, what time are we done today? Move your head, move your big fat head. Oh, good, we have 20 minutes. We might even be able to. I'm gonna have you guys come up here. And I think from here on out, I'll just have what you might want to grab sitting on this front table so that when you come in, but you didn't know that. So today, the next on the schedule is to work on the limits part of it. Oh, I forgot something. So just wait. You guys are used to it, so I do all notes from the top of my head. So on the other side of your paper, don't forget limits as x approaches the infinities. Do we remember what those are graphically? If it's a limit is a y value, and if as I go to infinity, I do have a limiting value, so let's just suppose I'm just going to make a h of x, and let's suppose it equaled 2. What is 2? It's a horizontal, oh, it's awesome. It's a horizontal asymptote. As I go to infinity, my y values are bound by 2. Right, Zach? So limits at the infinities, be they plus or minus, provide horizontal asymptotes. Does that make sense? Now let's see. You guys were good at these, so let's just put a couple samples on here and see if you remember. All right, let's go to infinity. Let's do 2x squared plus 1 over x cubed. And you don't need to write it down if you're in here. People at home, you should. It's because you'll be uploading it. But what's that? And why? What is it? 0. Yep, and do you remember the rule? Yeah, if the bottom's heavier, it takes over and sends the ultimate number to 0. Does that make sense? Be careful of thinking higher power because it's actually higher function family as well. So watch this guy. Limit x approaches infinity. Suppose I had x to the, and again, I'm just shooting these off, but that. You should know that immediately. Maybe Lukey's like, I'm going to L'Hopital it. Sure. You'll get 99 x to the 98 over. What's the derivative of e to the x? 48x. And he goes, shoot, I still have infinity over infinity. Do it again. And again, and again, and again, and again, and again. Right? Until eventually, what will the top be? 0. And what's the bottom going to stay static at? E to the x. So it's not always the highest power. It is if it's a rational function, a polynomial, it's about where the more powerful function is. Does that make sense? So if it was like this, and so a lot of time, I think there's some phrase in pre-calc sometimes that they teach, like, I think it's bottom, big on bottom, 0 Bobo. You ever taught someone about Bobo? Good, because that screws people up when they are no longer exponents. All right, so what if I did ln x over Remember, if you don't know, you can always put your L'Hopital in it. If you don't know which one's a stronger function, by that I mean faster growing, which one's stronger, the bottom or the top? If you don't know, then let's take the derivative of the top. That's L'Hopital, so you can see it. What's the derivative of the top? And what's the derivative of the bottom? 2. So it'd be 1 over x over 2 or 1 over 2x. Now you should know the answer. What is it? 0, right? This guy is stronger. You might say, I don't know what she means by stronger. The natural log function goes like that. 2x goes like that. Do you see how the line overtakes it? Right? Does that make sense? All right. So we said if the bigger's on the bottom, it goes to 0. How about if the bigger was on the top? Let me just swap these out. You don't need to write it because you guys were really good at this. Now what does it go to? One of the infinities, right? And there is no horizontal asymptote. How do you decide if it goes to the positive infinity or the negative? Signs. Yep. Had this been, watch me tweak it, this, it's still going to one of the infinities, right? The top is going forever down. The bottom, no matter what I square, is positive. So what infinity is that? Negative infinity is the limit. What's the horizontal asymptote? You guys are impressing me. Doesn't exist. Oh, cool, right? Love it! Okay, so go ahead and pick up one each of the packets. Those of you at home today, the review packet is
I
attached.
think we do turn that.
So, Laura, do we take the notes and take like a picture?
Yeah, that's what the at-home people are going to do, so I'm going to have you guys just do it too.
Just the front side.
Yeah.
Take your time.
Normally I won't be doing like note submissions, but for the people at home, I want them, if they didn't take them, to see a 0 in the grade book and be like, oh crap, I was supposed to take notes. It's going to be too easy to think it's a day off, don't you think? All right, so we're going to talk about both of these. If you're like, oh my gosh, 2 big packets already. The circuit is tomorrow, and you should finish it in class. You can work with each other if we can figure out the Jamboards, or just, you guys, they're small enough class, you can just kind of say, what did you guys get for the third one? All right? So tomorrow is the circuit, okay? And those of you at home, you'll just get it tomorrow, so don't even worry about the circuit. But back to this schedule here, I do want you to start the skills review. There is no due date on it yet, so write due and just leave it. Okay, it means it's not next week. You know I always give you a good warning, right? It's not due yet. And let's talk about a few on that first page, all right? So, let's talk about strategy. I said that on purpose. Let's talk about, let's just pick up. Number 3, how could you approach that? You could do conjugate or L'Hopital. Depends on what, I actually like the conjugate for that type, but whatever. How about, let's take a look at number 9. Sine of 0 is 0, over 0 is 0, doesn't factor, no conjugate. What would you use? I'd L'Hopital it. Now, remember to L'Hopital, you have to have a little bit of derivative knowledge. What's the derivative of the sine of 5x? Yeah. What rule are you remembering? Chain rule. Yeah, so you do need to have a little bit of work with that. All right? So, it talks about asymptotes, horizontal, vertical, continuity. Let's go to the continuity on page 4 and answer the first one. I didn't talk about continuity because it comes back pretty quickly. Are you ready? So on page 4, it says, write the definition of continuity of a function at point C. We talked about continuity in Calc 1 today, but I did not talk about the 3-part definition. I just said, because we're graphing a piecewise function. And I said, is it continuous at 2? And I said, if you have to lift your pencil, the answer is no. They know nothing right now about limits. or continuity. But they did intuitively know they had to lift their pencil because there was a hole in the graph, or you know what I mean? But do you guys remember what the three things are? And let's put that on there. So if you want to work ahead, like if tomorrow you're like, nobody gave us anything, I want to get past page 5. Go ahead. I only expect you to do the limits page, the first page.
FSC.
Yes, there we go. I'm going to get a blank sheet of paper here. So, three-part definition of continuity. At, what did it say, at C? All right, so let's talk about what has to happen for a function to be continuous. 3 things. What's one of them? Yes, f of c must be defined or must exist. F of c must be defined. What that means graphically is you better not have an open hole there. So let's define it. Boom. That certainly isn't enough. Right? Now I need to prevent the gap in the graph. So Callie, do you remember the second thing?
The limit from the left.
Yes, excellent. The limit as I approach C from the left better match up to the limit as I approach C from the right. Excellent. That prevents the gap in the graph. But here's the function that meets both of those and still has a problem. Limit from the left equals limit from the right and undefined there. So what's the third thing? Yeah, that limit better be where f of c is. That dot better, sorry, it's moving the whole graph. That dot better be defined at the location of the limit. So notation limit. And today maybe they would have said, yeah, that's continuous. But they couldn't write this out, right? Limit x approaches c of f of x. And what did you say it has to equal to? F of c. And we don't talk a whole lot about continuity. Except let's look at number 3. How do I force it to be continuous? Well, number 1, is it defined? Yes. Because of that equal to bar, right? So then do you remember what we do with these? I feel like you guys are remembering this. Yeah. Set them equal to each other and plug in the what? -1 for what? X. Yeah, you're going to force them to meet. You're going to force the y value of the line, kx minus 3, to be the same as the y value of the parabola, x squared plus k, by setting them equal. And I don't know what the answer is. Do you guys know? What'd you get? -2? Okay. So k would have to equal -2. What do you think? Alright, so when is this due? I don't know yet. At some point, I will give you a due date, and on that date, there'll be a Google form submission for this whole thing. Okay, that is not it. Tomorrow, you have to do 2 things just to make sure you understand how the attendance works. You have to go to campus and check in for me, right? And then it's going to say to do and turn in a circuit. If you don't do that, then I'll uncheck your attendance. Yes?
Do you check into the campus like just once or is it every class?
Every class? Yep, and then you have to somehow interact with every class. So suppose all of you turn in the circuit, it's set Lucy. I'll go to Lucy's attendance tomorrow and I'll uncheck her in.
Is it by midnight?
We're assuming most of you will check in and do your work. So it makes it easier so we're not clicking on it. I hopefully, especially the AP class, I honestly shouldn't ever have to uncheck you in. I'm assuming you're doing this to get college credit. You're going to check in every day. But like for freshmen, they, in distance learning, kind of like decided to take the days off. Yes.
So say we're here this hour, and then you don't post until next hour. So what time do we have to have our stuff done by?
I usually would have my due dates by midnight. I'm going to stick with that.
So if it's not done by the next day, then you aren't sending.
Yeah, we have to finalize the attendance for the week every Friday. So I'll go in and I'll say,
What if I like work? I put my availability down to like 2 close some days. So I might like try to like talk to you about it.
Yeah, I'll be nice. You're welcome. And there's still recording.